Hello, Chemistry. I'm here to go over mole conversion and formula quiz corrections so you can correct your quiz and prepare yourself for the final. First set of questions was formula mass. The first question itself was this one with ammonium phosphate. And you just need to figure out the formula mass of that. Not that hard to do. I had recommended doing a little chart type thing indicating all your elements. So there's your four elements that are involved. You need to get the formula mass, which you need to use the periodic table. That would be 3 times 14 for nitrogen. And then 12 times 1 for hydrogen. And then 31 times 1 for phosphorus, and 16 times 4 for oxygen. You're going to end up adding all those things together. And if you do that right with units, well, let's go ahead and finish these partials, because I think this is going to help you with the next question. So it's 48 plus 12 plus 31 plus 64. And you get 149 grams per mole. Just watch your rounding and take it from there. That now tells you your total. This is your total from the periodic table. And then these are all your parts. All these little guys here are your parts. And this is your total. So when you get to the next question, you'll see how that works. Actually, the next question here was another formula mass problem for iron sulfide. I'm going to skip that one because most people did well on that. But the final answer was 207.6 grams per mole. Just be careful how you round iron. I'm going right now to the percent composition problem, so question number 3. Percent comp. Okay? Basically it says, find the percent composition of each element in ammonium phosphate. Use your data from question 1. Well, again, looking back to question 1, this data, there it is. We have all the parts and we have the total. So that's all you got to do is plug stuff in. We have 42 over 149. That equals 28% nitrogen. We have 12 over 149. And that equals 8% hydrogen. We have 31 over 149, and that is 21% phosphorus. And we have 64 over 149. Again, times 100 if you're following that kind of thing. I'm doing the quick version here. That's 43% oxygen. Again, all those numbers should add up basically to about 100%. That's all you have to do for question 3. Next question. Hydrate lab. I call these the Dr. Frank type questions. Question number 4, part 1 says, what is the percent oxygen in iron 3 oxide? Here's the easiest way to do this. We have iron, just do it in words, plus oxygen makes iron 3 oxide. Elements and the compound, or the parts and the total. So they've told us in the problem iron is 5.6 grams. Oxygen is 9.4 grams. So my total, if I add those two, that's the trick on this problem, is 15 grams. So to do the percents, and they just ask for the percent of oxygen here, 9.4 divided by 15. I'm not showing the units for sake of time, but the grams here would cancel out and you're going to get percentages. And you get 62.7% iron. I'm sorry, percent oxygen. And you could figure out the percent iron the other way if you wanted. Part 2. Now we're going to figure out the percentage of water. All right, here's what they give you in the problem. They tell you that before heating, you have 6 grams of total substance, whatever it is. After heating, I'm just going to write after there, you have 4.7. If you subtract before minus after, is going to equal to water. So 1.3. That's how much water evaporated from the substance when you heated it. All right, so percent water, part over total again. 1.3 over 6 times 100. I'll even throw it in this time. Equals 21.7%. That's that question. Next question. All these unit conversion problems. The answers I gave you in class, I guess I'll go over these quickly here. We have for number 5, you have 200 grams of some substance, which is actually, I'll write it out, cesium phosphate. So you do need to get the formula mass of that, and you're just going to basically divide by it. But remember, we write division, since we want to convert to moles, as 1 over the formula mass. And the formula mass here is about 494. Again, this right there is from the periodic table. So you'd have to look up all of this stuff to get it. And we get, final answer, another arrow, 0.405 moles. That's it. Question 6. How many grams are in 16.1 moles of barium chloride? Always write down the number you're given, 16.1 moles of BaCl2. Now I need to go the other way with my conversion. I need to cancel out my mole unit, and I need the formula mass of barium chloride, which ends up being 208.3. I should have shown my unit cancellations in the last one. That's the reason the setup is like that. This unit at the beginning will cancel the unit that's in the denominator, and I'm left with just the unit I want, which is grams. And the answer here is 3,354 grams. Next question. How many grams are in 1 molecule of water? Dr. Frank question all the way. Start with the thing they give you. Molecule H2O. I do these all in one step, so I'll try to show it here like that. I want to convert molecules to grams, but I have to go to moles first. And here's where I use Avogadro's number. Okay? Molecules will cancel out. And then, to go to grams, again, my unit setup is moles need to cancel. And 18 grams per mole is the formula mass of water. So this is really a two-step problem maybe. 1 molecule divided by Avogadro's number multiplied by the formula mass of water. Bottom line, the answer is 2.99 times 10 to the negative 23rd grams. A really, really, really small number, which makes logical sense. On the back, we have the empirical formula type problems. Questions 1, 2, and 3 are type A. What does type A mean? Reduced subscripts. So if I want to go from C12H22O11 down to it's reduced, it's the same darn thing, because there is no way to reduce that. So that's the answer. For caffeine, C8H10N4O2, those are all divisible by 2, so you get C4H5N2O. For hydrogen peroxide, That's the molecular formula. The empirical formula is just HO. That one's done. That's all you have to do for type A. For number 4, question number 4. This is a type B. So it's like a 3-step process following your help sheet. Write down the given grams. This one takes a little bit longer. And it's a good idea to just show as much as you can with units. Grams of sodium, just so you don't forget. This is grams of sulfur, and this is grams of oxygen. All right, now, a lot of people made this mistake. I don't divide by 100 or do anything like that. I'm not dividing yet. Well, I am dividing, but I'm dividing by formula mass again. So you need to divide by formula mass. Periodic table. Okay, now this is going to get a little crammed here because I want to try to show my work. Notice they're all different amounts because all the atoms have different sizes. That's a 1 mole on top in every case. Oxygen, 16 grams per mole. If I'm showing my unit cancellations properly, I'm doing that. Now I get moles. 1.59, 0.79, and 2.38. Now is the step where you divide by the smallest one of these. And I think a lot of people wanted to do that on step 1. So now everything gets divided by 0.79. 0.79. 0.79. Forgive me for my handwriting there. It's just tough to get that to come out. All right. Answers now here. I'm just going to put the equals down here. I end up getting 2 for sodium. I end up getting 1 for sulfur. And I'm getting 3 for oxygen. And again, these are all moles. So that simplest whole number mole ratio of the atoms of the elements in a compound is the empirical formula. So final answer, Na, those become the subscripts, 2SO3. Next question. Type is number 5, is a type C. Type C is really pretty easy, and most people got this one right, but you're given NH5 as your empirical formula, so find the formula mass of that, and the answer is 19 grams per mole. That's from the periodic table again. Now I take the number they gave me, which was the actual formula, which is a factor of some whole number bigger than this. They gave me 57 grams per mole for my molecular formula. Divide that by 19 that you just found out, and you get a factor of about exactly 3 times. 3 times. What do? Take the empirical formula that you were given and realize that the actual molecular formula must be 3 times bigger than that one. So it is N3H15. Last one. Question number 6. This is the one that is a type D, which means it's really a combo of B and C. So you'll see that here. 39.24% phosphorus. Oh, and I already skipped the first step, but we'll fix this. And 30.76% oxygen. And the first step I didn't really tell you before is the magic of changing your percents to grams. Think about it as grams per 100 grams. So really, if I assume 100 gram a sample, that would be okay to do that. Now I do just what I did up top. So I'll show it to you one more time. Now I'm doing a type B problem. Oh yeah, I'm converting grams of phosphorus to moles of it. 31 grams per mole. Oxygen, same thing. Everyone should know 16 for oxygen. My grams cancel out. My grams cancel out. I get 1.26 moles here and 3.79. And again, those never seem to be a relationship, possibly, if you're not looking at the math in your head. But when you divide them out, which is why you should do this step, when you divide them out by the smallest one of these moles, just like we did up top in question 4, okay, this comes out 1, and this comes out 3. So my empirical formula is 1 of the phosphorus and 3 of the oxygens, PO3. All right, now we're basically going to do a type C to finish this up. Now we know the empirical formula. We can get the empirical formula mass, again using the periodic table, and that comes out to be 79 grams per mole. If I take the 158 actually, that they gave me, divided by the 79, that gives me my factor. That comes out to be almost exactly 2. And if I take that 2 times the PO3, I can get my P2O6. That is how you do all these problems. To fix these, you need to show your work to get full credit.